Hello grade 12s, welcome to my channel. Let us look at something here. Obviously folks, this also applies to grade 11s because the hyperbola is also a topic that is known from grade 11. So it recurs in grade 12. So you should be able to handle it. Of course, there may be some spices from grade 12 from time to time, but mostly it stays as it is in grade 11. Okay, so we're going to handle this question 4. I hope you guys buckle up well and study along. Okay, we are given a function h of x is equal to minus 2 divided by x minus 2 plus 2. Okay, this is a hyperbola, and the fact that this is negative, we often take this negative and associate it with our numerator of that fraction. And obviously this already tells us that our a value is less than 0, and that implies our graph is going to appear in the second quadrant and fourth quadrants. Okay, so that's the structure of what we expect if we are to put it on the Cartesian plane. And of course, remember, this is just a framework. We will essentially draw this with those x's shifted as shown on the graph. But we're just simply establishing what is going on. Okay, so I mean, this is a full equation. We can do anything we want. So let's just jump into the question itself. 4.1, we need to write down the equation of the asymptotes of h. Of course, the x1 is going to be x is equal to 2. The trick here is to take that denominator, equate to 0, and solve for x. Okay, and the second one is going to be y is equal to 2. We take that 2 as it appears on our equation. So if it is positive, it's 2. So that constant right there will always be the the horizontal asymptote. And the vertical asymptote is taken from the denominator being equated to 0 and solving for x. And it gives us x is equal to 2. So those are easy 2 marks. And then we move on to 4.2. We need to calculate the x-intercept of h. Okay, we know that for x-intercept, it is such that 0 is equal to minus 2 over x minus 2 plus 2. This will imply we transpose the 2, it becomes negative, and since we have fraction, this is over 1, is going to be equal to minus 2 over x minus 2. At this point, we do cross multiplication. So what this is going to give us is, we would say minus 2 times x is going to be minus 2x. Minus 2 times minus 2 is going to be plus 4. Is equal to 1 times minus 2 is minus 2. And then we continue. We will see that minus 2x is going to be equal to, transpose the 4, we get minus 6. We then divide by 2, and what does it give us? 3. Okay, so therefore the x-intercept is such that 3 is to 0. At times, I don't know if you really need to show it in the ordered pair or not, but often just do it. Okay, just do it. So this was just 2 marks. So the most important is this substitution of 0 and essentially getting the answer. So that is just the easy 2 marks there. All right, let's move on. So 4.3, we need to draw the sketch graph and show clearly the asymptotes and what. Since we're running out of space, we may as well do it on the next page. So 4.3. So we know that, oh, by the way, we didn't check the y-intercept. So we know that first we need the y-intercept. For y, intercept, it will be such that we have h of 0 is going to be equal to -2 divided by 0 minus 2 plus 2. We'll say therefore h of 0 is, now remember this is -2 divided by -2, that's 1. 1 plus 2, that's a 3. You can say therefore the y-intercept is such that 0 is to 3. Now this is very important because we needed it. And then we can do the sketch. Okay, so this is the x-axis, that's the y-axis, that's the origin. Now, we know that the y-intercept is at 0 and 3. That's not a big deal. But now, where's our asymptote? Is at 2. So we can say that should be our vertical asymptote. It looks all right. Of course, it looks a bit slanted, but it's not a big deal. So we always break it up to show that it's an asymptote line. And then the second one is at 2 as well. So we can say this is 2 over here as well. And we can break it up. So that we can label as 2. This one is also 2. Okay. Now we need to draw the graph. So we know the graph has a y-intercept as well as an x-intercept. But now what did we get for our x-intercept? We got 3. Yo. We got 3, so it's here. Let's say this is 3 over here. And then the y-intercept is also at 3. Say that is 3 over there. So our graph is looking like this. Okay. So I must take care not to intersect. Okay, it looks like my 3 is a bit off. And that's how it's gonna go. All right, nice and easy. Of course, it doesn't really have to be a lot fancier or whatever. We just do it. So there it is, guys, and we just label this as h somewhere. Hey, why is my h always crazy? Anyway, so this is the graph, guys. Anything else? No, because we've labeled the x-intercepts, right? We've shown the asymptotes clearly, and that's the graph. So we get 4 marks. So we get a mark for the shape, right? And we get a mark for any one of the intercepts. We get a mark for any one of the asymptotes. What else was there? Clearly show all asymptotes and intercepts with the axes. Okay, alright, okay. So the fourth mark probably was to work out that y-intercept, okay? Maybe. Now we will do 4.4. It says determine the equation of the axis of symmetry of H in the linear standard format where m is less than 3. So this one is easy because we're going to write here y is equal to minus x minus p plus q. So this is the best format. Okay, so what we are going to do, so I see a message there guys, but let me move quickly. So this implies that y is equal to minus into, now what is x minus p? It is exactly what we see on the equation that we were given. It's this guy right there. So we write that x minus 2. Alright, and then plus 2. The q as it is. So we write that equation as it is. Alright, so this is good. So this is the x minus p is what you see on that denominator as it is. And the q is also as you have seen it in our equation. So therefore y is equal to minus x. So minus times minus is going to be plus. Therefore 2 plus 2 is 4. So we are done. Okay, so that's good. That's the easier way of doing it. But at the same time, we also know that technically, we also know that one could also sort it out this way and say y is equal to minus x plus c. Because we know the gradient is always minus 1. Then we substitute the point of the intersection of the asymptotes, which is the center of the hyperbola. So we will write here with this point 2 is to 2. 2 is going to be there, minus into 2 plus c. Therefore c is, transpose that, it becomes 4. We can say therefore the equation is going to be minus x plus 4. What you need to know is that this point is the center of our hyperbola. The center is always the intersection of the asymptotes. Please remember that. Okay, good. Now let's have a look at other things. What are the other things doing? What are these things doing? They are doing what they are supposed to do. All right. Okay, so how many marks? 3 marks. Great. So we get a mark here for the substitution and the answer. Question is what? Maybe we can just award for the format. It really doesn't matter. This is a 2-mark question often, because even here it's just this and that. Yeah. So maybe knowing that the standard format will be like that, it's 3 marks. It's not a big deal. So 4.5 says, determine the range of h of x plus 1. We know that minus h of x plus 1 is essentially equal to, now we say here minus into minus 1 over, 1 over x minus 2 plus 2, and we add 1. So that's the notation. So negative times negative is positive. Then this becomes minus 2 plus 1 is going to be minus 1. That's the equation of our situation here. So just know how to handle this. Tonight, guys, I'm going to have a lesson at 7 with my grade 12s. So you can join in. Maybe these days I'll try to learn how to do the lives so that you can all benefit, even if you are not in the group that we created. So we know that the range, guys, is only limited at the horizontal asymptote. We can say therefore the range is equal to a set of y values such that y is an element of all real numbers except that y is never equal to minus 1. This is the set builder notation. Aibo. I win. Okay, if not link. So that's the one, guys. But again, even if you didn't write all of this, you can just write the range is such that y is an element of real numbers so that y is not equal to minus 1. That's all right. That's easy. Or one can write the interval notation that essentially y is an element of, we write negative infinity going up to minus 1. That bracket is written like that, and then you union it with a round bracket again going to positive infinity. In fact, I made an error here. Infinity is never included. So that's another way of writing the same thing that we wrote. And as I said, guys, you can easily write just this portion of the story only without using any silly notations. That's still acceptable. So you get a mark for this business and that restriction, essentially. Here you get a mark for each of those brackets, I guess. 2 marks is fair. Now the last question. So 4.6 says determine the values of x where h of x is less than 0. Now obviously, guys, it means when is this graph negative? This graph means it's negative or appears below the x-axis and at the x-axis, because the equal to part is including it. So this means this graph will appear below and at the x-axis. So when do we see this? We will see that, well, if we just shade this, we will see that this is where the graph is at the x-axis and below the x-axis. So this is this interval here between, it's this interval right here, okay, between 2 and 3, but 2 is an asymptote, it's not included. As we can see, this one is above the x-axis, so it's out. So we'll write here that x must be less than or equal to 3. 3 is included because 0 is included, but this must be greater than 2. Again, we get a mark for those two notations. We get 2 marks for what we are doing. So guys, a very easy thing to do just to keep you going. Otherwise, you could have handled this during your own practice, even if I didn't show it. So I hope you have learned something. This is from the Free State Trial 2023, for those who are interested in checking the paper out and essentially working it out. So this is how a question of this nature is to be handled, and hopefully, guys, these become easy marks if it gets asked in the exam. Otherwise, I will see you later at 7. And for those who are not in the group, I'll see you some other time. Goodbye.